Good afternoon, muffins, and happy 2026. So, what's your favorite genre of music as a fellow nerd? Okay, frick that one. Ah, yes, this is where the good shit is at. Oh, so I've been more hammered than the roads in Montreal for my 2026 party, so today we're ranking sorting algorithm pieces by how good they sound. Now, in the true spirit of sorting algorithms, I'll be sorting them, but I'll do it freeform, like any sane human being sorting a small list of tangible items. Cause ain't no way I'm running formal merge sort in my brain while I am in this state. Now, most of the sorting algorithm visualization video on the tube come from this one program coded by our homie, Timo Bingman. I can go to their website and download the code. I have went ahead and compiled it myself. Works surprisingly well on more than Windows 10, considering it is a program coded in 2013, which is 13 years ago. Okay, so as you can see from the, awkwardness here, this is gonna be basically my first unscripted video. Okay, I'm gonna have fun. Okay, let's go. I will stutter quite a bit and have some take from my Tourette's, but I reckon they will be edited out by the time I, edited the video. Okay, let's go bubble sort. Okay, I mean, not bad. It's very standard beginner sorting algorithm where it's a nested for loop. So it will have, n square time complexity, goes around pretty nicely. And as the list is being sorted, the larger elements go to the end and it gets faster. So it's quite nice, satisfying. Now, insertion sort. Okay, so you insert each element to the sorted list near the beginning. So since it's a nested for loop, it's also n square time complexity. So, and then you will see because the sorted portion is pushed to the beginning, so the tone get higher instead of faster and lower. Not bad. My opinion of it is around bubble sort compared to bubble sort. Whatever. Okay, and then binary insertion sort. So instead of just inserting by checking every element, since in the beginning the sorted portion of the list is of course sorted, it used binary search, so it's quicker. But in data structures where insertion takes n instead of constant time, so it will still come up to like n square time complexity. It's quite a bit faster because it optimizes a find and insert step using binary search, right? But sound-wise, it's less interesting, I would say. It's definitely less interesting. Okay, let's go. Selection sort. It's still a nested for loop sort, so it's n square. It selects the smallest elements and move it to the beginning of the unsorted list. So instead of inserting into a sorted portion, we append to like the side of the sublist. It's quite a bit faster depending on the specific data structure you use. Again, it's still n square, so nothing special, right? Sound wise, it's definitely is less interesting than insertion sort. It does have the emblematic, like, getting higher towards the end because as more of the list is being sorted. Okay, now quick sort. Okay, there are different variations of it, and we can select from here, which I will use the version with the 2 pointers on the left from CLRS. Yes, CLRS, the holy text of computer science students. Let's run it. Well, it's quick sort, right? It grabs some element and partition all element larger than it to one side, and all elements smaller than it to the other side, and then it keep recursively doing it until it's completely smooth and sorted. Not bad, but not interesting either. Sound wise, it as a music piece is not interesting either. Maybe a little bit better than binary insert. Now and then for our first actually optimized sort, we have the top-down merge sort, which is, of course, as we all learn in our class, has an n log n time complexity because of recursion tree structure, and it divides and conquers, so it gives you that optimal n log n time complexity. So we can use a larger list. Let's see. Okay, so due to recursive structure, there's definitely both a visual and audio fractal going on. As it's built up, right? As it take the two sorted list and merge step them into a larger sorted list, you go like, but it's quite nice. It's quite nice and quite interesting, but I might also be biased towards, I guess, it's the best to implement, I guess. But then, here's the interesting part. There's another version of merge sort. Here it's called iterative merge sort. I like to call it bottom-up merge sort. So the difference is that top-down merge sort split the list in half, and you have a recursion call down the first half, and then after that is sorted down the second half, and then combine them using the merge sort step, right? But the bottom-up merge sort goes up in power of 2. It takes the first two elements, combine them, okay, sorted. And then the third and fourth, okay, sorted, right? And then you combine the first two length list, and then you build it from the bottom up. So that's why it's called bottom up. So let's run it. Yep, you hear it, but definitely much more interesting. Because of its bottom up, right? So it go through the entire list and then build them up towards the final sorted list instead of splitting and doing one part and doing the other part and then recursive combine, right? So in the middle of it, right now in the middle of it, you can definitely see there's like this clear pattern going on. These like small sorted list of length 2 to the n, 2 to the I, right? I being the step, right? These small sorted portions, and then you combine them. So, and then at the end, they keep being combined, and then you have every pair. You have a slower like ascending. You have a slower ascending tone, right? As the patterns combine until at the end they just all combines into one sorted list. So this is just goated. This is just, it sounds so good. It sounds so, it have the right amount of tension, and it sounds so satisfying. Like, when it's like working towards the middle, near the end, and then towards the end. So this is just goated. This is S tier. Now we have an interesting one. It's called cocktail shaker sort. So basically what happens is that it's bubble sort, but it goes two ways. It bubble towards the end, bubble down backwards towards the beginning, and then the smallest elements stay at the beginning, and then until it shake until it come back. I guess it's an interesting optimization over bubble sort, but in essence, it's still two nested for loops. So of course it's big O n square. Definitely sound quite interesting, and by nature of being an iterative sort, it gets faster in the end. So it swing, but it have the added bonus that it swings around in the middle towards the end, right? As it get faster and faster. So I would say it's a solid, well, it's a solid A tier sound wise. It's maybe even better than top down merge sort. Yeah, let's put it there. Let's put it there. Next we have well, I would say this is my favorite, heap sort. It's basically my favorite sorting algorithm because it's the most fun to implement and the most fun to see, and you can visualize in like many different ways. But right now in this program, we'll just run it. Well, the colors, right? Well, okay, so right now it's like in the middle of like at the beginning of a sorting phase after you build a heap, right? Right now you can clearly see the colors of the bars, right, are in different sections. This have 1 yellow and then 2 magenta, 4 orange, 8 pink, and then right, the colors are like the layers, like the levels of the tree, and the largest one, right, larger than these two, and then these two, this one is larger than the first two, this one is larger than the other two, and then each one of these third level, right, notes are larger than the 2 consecutive items in the next layer, and then as you sort it sift down, and then the other notes are promoted up, right? Again, even in this way, right, there are other visualization where you literally draw out the tree in your system, right, in your visualization system. Sound wise, it's not too good, but compared to selection sort, I can definitely bubble sort it up, and it's better than insertion, but it's nothing special about it. It doesn't have the satisfying like right combinings, satisfying a stint of the merge sort, right? Okay, next up we have LSD radix sort. No, not that LSD. Least significant digit. We essentially grab out buckets and sort them into buckets, and for each digit, and then at the end you combine all of them into a sorted list, right? It's also recursively. So technically it can break the n log n optimal limit of comparison sorts, but it have another constant in its expression there, n times k, because k is the number of like digits in the maximal amount of digits in the numbers as element, right? So let's run it. So I'm pretty sure this is like a binary, like a radix, so like a base 2, right? So in the middle of it, like you can definitely see there's this where you have like the small sorted portions as like a pattern in the middle and towards the end, and then as they combine into a one big sorted list as a final product. So it's definitely quite nice. I would say it deserves S tier. Yeah, I would say it deserves S tier, just like bottom up merge sort. Again, it's just so satisfying seeing the pattern combines into one. I could bubble it, but no, it would stay there. Okay, next up is the opposite of least significant digit, right? So it's most significant digit radix sort. So basically, it's also radix sort, right? It puts the item in the buckets by the digits of the number, but this time it used like the most significant digit, and it recurs down to the smaller buckets within each bucket. There definitely would be a less of a fractal pattern. Right, it definitely have like less of that pattern because like you sort them by the most significant portion first. So the largest goes towards the end immediately, and the smallest goes towards the beginning immediately. Because starting, as you can see here, right? Because starting at the beginning, it already looked like sorted, and it seems like all you need to do is just comb out the inequalities into like a smoothness. So like sound wise, is definitely in the same as like quick sort. Yeah, it would stay there. Yeah, it would stay there, but like, cause like quick sort. Okay. Okay, now we have the meme candidates, right? Stooge sort and slow sort. So basically, stooge sort is the I'll turn it into a smaller array size to make it be able to finish, right? So basically, stooge sort, it's not even optimal. It's like big O n to the 2.75 or something. It's even worse than dual iterative like 2 for loop sorts that are n square. And so basically what happens is that I'll read it off the Wikipedia page, right? You split it into 3 parts, right? Each recursion step, you do the following. You do the initial 2/3, and then you do the final 2/3, and then you go back to the initial 2/3. And then you return back up a level, right? In terms of recursive call. So it's a time complexity. It's basically, yeah, not good. So essentially, stooge sort is basically the vermin supreme of sorting algorithms. It's a meme. It's like it's not meant to win. I'll run it. You can definitely see the recursion, initial first, and then final 2/3, and then back to initial 2/3, and then you recursive call, and then you recursive back up, and then, like, okay, sure, visually, right? It's infuriating to watch because it's just so unoptimal. Sound-wise, it's not bad. It's like, sound-wise, it's just not bad, but not good either. It's certainly interesting. So I'll put it. I'll drop it at C, but I could bubble it up. It's still more interesting than binary insertion. Okay, finally, we have slow sort. Yes. Okay, so you might be asking, well, deep fried pancake, where is the famous BOGO sort? BOGO sort is in this software, but I'm not gonna run it. Hi, future pancake here. At that point of the night, I was just stuttering so much, so I might as well record a new clip. So basically, no hate on BOGO sort, but 1, it's gonna take a day to finish a 10-element list, and 2, it does not have any progression throughout the run. So sure, it's still a piece, but I'll just give it F. Because even within modern art, I like the ones that convey a meaning, I guess. Again, like, no hate. Okay, slow sort. It's just, I'll read off the Wikipedia page again. It's just called multiply and surrender, right? So basically what happens is that, and you recursively go down, right? Each call, you sort the first half, sort the second half, find the maximum, right? Comparing the largest in the end of the first and the end of the second, and then place it at the end. And then you keep going instead of utilizing the fact that you now have 2 sorted lists and merge sort them together. And this is just so atrocious. And according to the Wikipedia page, right, if you take this and scroll, it's exponential. It's like, how? It does sound quite interesting. Again, you have to break your sorted list. This is just trolling at this point, just like stooge sort, right? This is just meme candidate. Sound interesting though. And just like how the other two nested for loop sorts, like insertion, selection, and bubble, it definitely have that pattern of getting faster, right? Getting faster before it's fully sorted at the end, kind of pattern to it. Yeah, I would say it's quite nice to hear, but of course, like algorithmically, it's infuriating. But like, it's good. It's not bad, and it's quite interesting, right? Now, is it better than insertion? I'm not gonna bubble it up. Okay, yeah, that's it. That is the tier list. There's no D tier. I'll remove it. I'll delete. Okay, back to post-production DFP again. As you can see, at the bottom are ones that don't have a distinctive pattern, and then there's iterative ones in the middle, and the ones I like the most have a build up into accumulation. Well, yeah, that's it. So this wraps up my first attempt at unscripted, spontaneous video. Well, I guess I tried. Now, do tell me if there's anything I can improve though. Your feedback is how I learn. And as usual, like and subscribe, and here's to a great 2026. Cheers. See you later.